So now we'll talk something like normal distribution. So after completing all sampling and all, so normal distribution feels somewhat confusing, but if we understand, means it is very good concept. So let's try to understand what is the normal distribution, and let's start dive into the topic. So normal distribution is something like a bell-shaped distribution. A bell-shaped, here is bell-shaped, right? A bell-shaped distribution where the most values are near to the mean. So for example, we can see that the normal distribution which is in bell shaped, and that is used to find out the mean of the data. So the mean, low, and the mean is the average, right? So mean means average, and this is low and this is high. I hope you understand this. Okay, let me explain clearly. For example, if we take 1,000 students writing an exam, most students score around 50 marks. Very few students score 0 to 10 marks, means very low, and 90 to 100 marks will score very high. Means here is the bell shaped, means if you see low, average and high. So here 0 to 10% will get only 10% or 2 people, and 10 to 20 will get only 5 people, and 20 to 30 will get 10 people, and 30 to 40 will get 15 people. Like this we are getting, this is the average. Like we'll see low, medium, high. So mean is average. For example, we can see another example. I can say that height, human height. Like for example, one human, the maximum average height is 170 centimeters. Out of 100 people, the most will be between 165 to 175. Fewer people will be 150 centimeters. Very fewer will be 130 centimeters, and very fewer will be 210 centimeters. Like so, here the data looks like the fewer people having 40 centimeters, means 140 centimeter, and average people having the 160 centimeter. Average means mean. So most people having the 170 centimeters, and few people having the 200 centimeters. So like that we are taking. Normal distribution means most values are near to the average, and the very small and very large values are rare. Most values are near to the average, and very small and very large is very rare. So this is the explanation for normal distribution. So once again I am explaining, a normal distribution is a bell-shaped distribution where it having the most values near to the mean. So the formula is like f of x is equal to 1 by sigma of 2 pi e of minus x of mu by 2 sigma square. This is the formula of normal distribution. And how we are calculating, f of x is equal to mean, and so we are calculating like this: low, average, high. So here also the properties we are taking 68% to 95%, 99.7 rule. So let me explain that one also. Once again guys, some problem is there. Yeah. So this is the most common. So now we see what is this rule: 68, 95 and 99.7 rule. So it means like 68% of data or values lies within the first deviation. Means 68% of values lies between the first deviation, and 95% of values lies within the second deviation, and 99.7% of values lies within the third deviation. So it tells like how much deviation, how much the variance in the mean, where it comes to low and average and high. So this is the deviation. This is 3 types of low, medium, high, average. So we can say like mean, if the mean is 170 centimeters. So if we take a 170 centimeters, means if standard deviation is equal to 10 centimeters, only 68% of people lies between the 160 centimeters to 180 centimeters, and another 95% of people, means 95% of people lies between the 175 centimeters, sorry, 150 centimeters to 190 centimeters. This all getting by calculation only. So 99.7% of people lies within the third deviation, which is 140 centimeters to 200 centimeters. So this is the properties of a normal distribution, and we talked about the shape of the distribution, why is the shape of the distribution and where it is useful, and the formula of distribution. And here mu is mean and sigma is the standard deviation, and we talked about the shape. We understand about shape, and we also talked about properties of it. And then I will explain about examples now. Okay, we are talking all this, but what is the uses of it? What is the where we are using in machine learning? Why we have to take this? So now I will explain one by one. So in real world data sets approximately follows the normal distributions, and height, weight, exam scores and IQ scores measure errors. So we can find out in height we can use weights, we can use exam scores, we can use IQ scores, we can use measurement errors, we can use understanding the distribution help us analyzing the data correctly. So in machine learning, where we are using it in future scaling, we are using in future scaling. Where we are using future scaling, many algorithms performs better when the data is normally distributed. So example, logistic regression and SVM neural network. So our next topic is coming on this, where logistic regression, linear regression, support vector mission, and also all this topic we are going to learn in next videos. So anomaly detection means detect unusually values, outliers. Example, average salary. Anomaly detection, what is anomaly detection means? Detect unusual values. For example, we are taking average salary is equal to 50,000, okay, and someone else like 1 lakh, and this may be considered as anomaly. So average salary is 50 lakh. So for example, we are three group of friends. I'm earning 50,000. The average salary is 50,000. Another is earning 20,000. Another is earning 1 lakh. Means I'm the middle. I'm the average 50,000, and low one is 20,000, and high one is 1 lakh. So this is one, anomaly detection. And statistical testing, it is used in hypothetical testing, confidence test intervals and Z test. This also going to do one video on this one, hypothesis testing, confidence intervals and also Z test, because this is very important. So in fourth one is regression. Linear regression assumes residential errors are normally distributed. So this is the Python code. I hope you will try your own. So this is the Python code, and I will explain one by one. Where import numpy as np, we are importing numpy for numerical operations, and next we are importing matplotlib.pyplot has plt, importing math for plotting graphs. So in line 3 we are taking data is equal to np.random.normal 50 10,000, means we are creating 1000 random values. We are creating 1000 random values and from normal distribution, and parameters like 50 and 10, means 50 is like a mean and 10 is like standard deviation, and also 1000 is number of values. For example, we are generating 48, 52, 61, 44, 55. Example, your wish, as your wish. So most values will be near to 50. If we take numbers like 10 to 6, 7, 8, 9, most of the values are lies near to the 5, right? So likewise. So now we are taking plt dot historical data, where Instagram shows how frequently values occurs. So plt dot show. So, okay, display the graph will look approximately like bell curve. Okay, I will run this one. I'll try to run this one. 1 second. I'll run and I'll come again. So I run the program, where import numpy as np. We imported matplotlib for which were the graphs and data, and we took 50, 10,000. We are taking 1000 records, and 50, 10 is the minimum and maximum records, and historical Instagram we got and plt dot show, and we got like this. So we'll got graph like this. So I hope you understand. So now the Python example is also over. Now we are going to see the quick interview answers. I think you will also practice, and also you will be able to learn with me. And let's see what is the quick probability questions that gonna ask in any interviews. So now first what is probability? Probability is measures that the chances of occurring the data or occurring the event. So what is conditional probability? Probability of event occurring probability of an event occurring given as occurred. So already we've seen some examples on it. So what is bias theorem? Bias theorem is something like updating probability based on the evidences. So what is sampling? Sampling is a like subset of the data from the population. So instead of taking a large population, we are taking subset from the population, and we are doing the calculation of it. And I told about try and test split also. Like what is normal distribution? Normal distribution is a bell-shaped distribution. Now only I explained, like most values are around the minimum. So these are the very important statistical problems where they are gonna ask in any interviews. So next videos we'll do some more statistical problems like hypothetics testing and A/B testing, and also confidence intervals, and this all, because these are also very important, and we are going to see random sampling and also, but not now. I'll now next video will come on linear regression, logistic regression, support vector mission, and then after we'll do another some 4 types of algorithm, and next video we're going to learn like 3 plus 4 means 7 types of algorithm in supervised learning. So let's wait for until next video. So please like, share and subscribe to my channel, and this is Anju and your Tech Alpha Anju. So